So we're going to start chapter 3 today. Start with section 1. Chapter 3 goes with polynomial and rational functions. In section 1, we're going to go with some characteristics of those quadratic functions, as well as how their graphs are going to work. All right. Now we're going to use those techniques that we developed in previous sections, specifically chapter 2. Just remember that when we're dealing with quadratic functions, we're speaking of functions of degree 2, or functions that have the highest degree attached to x is x squared. And every one of these graphs are going to be parabolic in nature, or graphs of parabolas. All right, so remember that in the general form, we're given the function f of x, which is equal to ax squared plus bx plus c. The biggest thing is that we can locate a, b, and c in the general form. And we're also going to use the standard form, which is a good way for us to see where the vertex lies. In the standard form, f of x is equal to a times x minus h quantity squared plus k. Now our goal is to take it from general form to standard form if it isn't already given to us in the standard form. All right, now some characteristics about it. Whether in the general or the standard form, we can easily locate a. A is usually the leading coefficient of the very first number that we see. So some things about it in terms of the graph of the function. So if a is positive, this lets me know that my parabola opens up. It's going to be tied to a minimum value, which we're going to go over. So if a is positive, the parabola opens up. And if our a is negative, the parabola opens down. Now, in terms of our range of the function, keeping in mind these functions are all quadratic, or parabolic in nature in this section. If it opens up, it's going to directly affect the range. If it opens down, it will directly affect the range. We'll go over that as well. All right. Now, we think back to 2.7, those transformations of functions, horizontal and vertical shifts. The number attached to x is going to be the horizontal shift. So in this case, whenever we see h, that represents our horizontal shift. When we see x minus h, it's actually going to be shifted to the right h units. So remember that horizontal shifts are the opposite of what we see. So if we see negative h, negative values on the x-axis, you'll think move to the left. But remember, horizontal shifts are the opposite of what we think. So if we see negative h, move to the right h units. By it, I mean the x part of our vertex. And if we see x plus h, that means we're going to move it to the left h units. So just remember that the horizontal shifts are the opposite of what we think. We see negative, move right. We see positive, move left. So our k, the number being added to or subtracted from, is going to be our vertical shift. Vertical shifts, they'll move exactly like we would think. So if we see plus k, we're going to move the vertex up k units. If we see minus k, we're going to move the vertex down k units. So we can see if the function is given to us in its standard form, a times x minus h quantity squared plus k, then we can take the opposite of what we see for h, exactly what we see for k, and we can get our vertex right off the bat. But they give it to us in a general form, to get our vertex, we're actually going to need a formula for that. And the formula is actually pretty straightforward. So we're going to go over the process here. All right, so our vertex is the highest point or the lowest point on our parabola. The vertex is always the ordered pair, HK. So like I said, if we give it to us in standard form, take the opposite of what we see inside the parentheses for our H, exactly what we see for K, we have our vertex. But if they give it to us in the general form, the way that we're going to get our vertex are from AX squared plus BX plus C. And if it's in either one of those forms, one side of the equation should be zeroed out. So here we're going to get equal to 0. To get our H or the X coordinate in our vertex, H will be equal to negative B over 2 times A. And in order for us to find K, that would just be F of H itself. So if we're looking for the vertex and it's given to us in a general form, we take the opposite of what we see for B, or negative B, divided by 2 times whatever A is. Get that value. Whatever that value is, we're going to run it through our function. Remember, we're going to have to give us F of X, and putting the value that we got for H in for every X in F of X to see what the Y is attached to it. Now we want to keep in mind too, in terms of minimums and maximums, that with parabola, it basically has one turn. Either turns going down or turns going up. So remember, if our A is positive, that means it opens up, or we're going to have a minimum. If our A is negative, that means it opens down, or we're going to have a maximum. So if A positive, we're going to have a minimum of whatever that K value is. Remember, our lowest point is going to be the Y coordinate on the X, on our vertex. But it's always going to occur at X equals H. So whether we have a maximum or a minimum, our vertex is going to represent it. If our A is positive, that means it opens up. Or we have a parabola that's shaped like a U, we have a lowest point, our minimum. If our A is negative, that means the parabola opens down. We have a highest point, our maximum. So if A is negative, we're going to have a max of K again, and it occurs at X equals H. So whether it's a maximum or a minimum, the vertex is what's representative of that. Now, the way that we can tell if we have a max or a min is if the A is positive or negative. A positive min, a negative max. All right, but the maximum or the minimum is always a Y coordinate. It always occurs at X equals H, or our X coordinate. All right. Next thing we need to go over, domain for our parabolas. Now, domain, we're dealing with a quadratic graphics of parabolas, always negative infinity to infinity, or the entire real number system. Well, our range is going to be affected by whether our parabola opens up or opens down. So the range are all the Y values. Our range will be K, or excuse me, open bracket, K to infinity, close parentheses. When our A is positive, or the range would be from negative infinity all the way up to K, close bracket. When our A is negative. We also went over how we get our x-intercepts and our y-intercepts. Remember, for our x-intercept, this implies that y is equal to 0. So the x-intercept is always the order pair x, 0. And typically, I will say usually, we have two x-intercepts. Sometimes we may have one x-intercept, and there are some times where we have no x-intercepts. That's going to be problem specific. But most of the time, we're going to have two x-intercepts. For the y-intercept, this implies that x is equal to 0, or the pair. It's going to be 0, y. And there's usually one y-intercept, even when we're graphing quadratics. So we're going to use these techniques along with the characteristics and get some good sketches, finding our vertexes, and to see if we have a max or a min, the domain, the ranges, and what those values are for our x and our y-intercepts. Giving a few examples. You guys keep in mind though, you do have a graphing calculator. There is no rule saying you can't use a graphing calculator to help you with these, or to at least check to see what you have, or to at least check to see what you're expecting, to make sure that it makes sense. All right, for our first example. Yeah, so copying. Yep. For our first example, we're given f of x is equal to x squared minus 4x minus 2. Now, the way that I would think about this right off the bat is I ask myself, is this given to me in standard form or general form? With the understanding that if it's given to me in standard form, I can just look at it and see what my vertex is. Or if it's given to me in general form, I can use the formula to find what the vertex is. All right, and the big hint for that, if it's in standard form, you'll see parentheses. If it's in general form, you won't. You'll just see it as descending order. All right, so they give us this one in general form, so we're gonna have to use our formula to find the vertex. Remember, the formula for us to find h is going to be negative b over 2a. Remember, the b term is what's in front of the x term. The a is what's in front of x squared. So here we will have a negative 4 divided by 2 times 1. And if we simplify that down, we can see that our x coordinate in our vertex ends up being positive 2. Because negative 4 gives me 4 divided by 2 times 1 is 2. 4 divided by 2 gives me positive 2. All right, so we have our x coordinate in our vertex. In order for us to find the k, what we're supposed to do is take our value for h and run it through our given function. All right, so our k for this particular problem will be f of 2, or we're going to replace every x in f of x with 2. So in this case, we have 2 squared minus 4 times 2 minus 2, or the y that's associated with the specific x that we plugged in this case 2, it's going to be negative 6. All right, so we found our vertex, which is the order pair, 2, negative 6. All right. Now this parabola opens up, and the way that we can tell is because our a, which is the very first value that we see in front of our a, or excuse me, in front of our x squared in the general form, is understood to be positive 1. Now, what's most important to us is that our a is positive. If the a is positive, then the parabola opens up. If the parabola opens up, this implies that we have a minimum value. Remember, if the parabola opens up, minimum opens down, maximum. And whether we have a max or a min, it's always going to be the y coordinate of our vertex. So here our minimum of negative 6, and it occurs at x equals 2. The domain for this function, the domain for all parabolas, negative infinity to infinity, or the entire real number system. The range, because it opens up, we're gonna have a minimum of -6. So it's gonna be open bracket -6. And there is no maximum, or it reaches all the way up to infinity. So our range, open bracket, -6, comma, infinity, close parentheses. Now for our x-intercepts, here we're actually going to have two. The easiest way to find our x-intercept, remember though, for our x-intercept, this implies that our y is equal to 0. If we look back to our original function, f of x is y, so we can make this 0 is equal to x squared minus 4x minus 2. And simply solve that quadratic. Keep in mind, depending on the calculator you have, whether it's the Casio or the TI, you have a quadratic formula already in there. So you can use the quadratic formula or you can solve it by hand. Now I'm going to go ahead and do this by hand really quickly here. Quadratic formula is -b, or in this case, -4, or +4, plus and minus the square root of b squared, and by b, -4, so that'll be 16 minus 4 times 8 times c, or in this case, 4 times a, which is 1, times c, which is -2. This is all being divided by 2 times 8, or just 2. All right, so it's going to give me 4 plus and minus the square root of 24 divided by 2. Bless you. How we simplify that down, we end up with 2 plus and minus the square root of 6. All right, now if you use the calculator, it's going to give you the decimal, which represents the square root of 6, because technically the square root of 6 is an irrational number, so it's a non-terminating, non-repeating decimal. Because the test is going to be multiple choice, you could always just plug in the square root of 6 to the calculator, see what that decimal is, or vice versa. Start with your answers to see which of those answers give you the decimal that you have in the calculator. All right, but we do have 2 x-intercepts. 2 plus the square root of 6 and 2 minus the square root of 6. So as an order pair, we can do 2 plus and minus the square root of 6, comma 0 for our x-intercepts. For the y-intercept, that's going to be 0 and -2. The y-intercept is much easier to solve, especially if it's given to us in standard form. So here we have x squared minus 4x minus 2. Y-intercept implies that x is equal to 0. So we have 0 squared minus 4 times 0, or 0 minus 0 minus 2. So our y-intercept, -2. All right. Now, to put it in standard form, the standard form of that same function f of x, which is x squared minus 4x minus 2, we open parentheses, x minus 2 quantity squared minus 6. And if we're graphing this, we know we have a minimum. Our vertex is at the order pair 2, -6. So we go to the right 2, down 6. It's going to be the lowest point on my graph because we know it's a minimum. This will actually be good enough for a sketch of our graph. Now we want to be accurate. We can always go in and make sure that we're going through -2 on the y-axis for our y-intercept and make it a little more accurate as far as our x-intercepts go. But remember, we know exactly what our x-intercepts are. And if we really needed a sketch of a graph, there's nothing saying that we could just plug this graph into the calculator. By that, I mean either the standard form, x minus 2 quantity squared minus 6, or the general form, x squared minus 4x minus 2. Either one will give you this exact same graph. So the biggest thing is that we pull those characteristics from looking at the function, whether it's given in the general form or the standard form. All right. Any questions on that first example? All right, more of the same. This time we're given the function f of x is equal to x squared plus 4x minus 4. All right, let's check for understanding. Is this one given to us in the general form or the standard form? Great, so general form. All right, so general form means we got these, our formula to find our vertex. The formula, so that H is equal to negative B over 2A, or in this case, negative 4 over 2 times 1, which means the X coordinate for our vertex, negative 2. The K, we'll have to evaluate F of negative 2. It's going to give me negative 8. All right, I'm going to take for granted we know how to plug this into the calculator and work this out by hand if necessary. All right, so our vertex is the order pair negative 2, negative 8. This parabola, does it open up or open down? Anybody understand? All right, anybody know? Opens up or opens down? All right, so for this one, it actually opens up. Remember, the way we can tell if the parabola opens up or opens down is I look at that A. If it gives us the function in general form, A is the very first, our leading coefficient, the very first term. Here it's understood to be 1 because there's nothing shown in front of the X squared, so our A is positive. If the A is positive, that means it opens up. Now, if it opens up, do we have a max or do we have a min? All right. Remember, if the parabola opens up, it's shaped like a U. We have a lowest value. That's our minimum value. All right. So this parabola opens up, which implies we have a minimum. Whether we have a min or a max, always the Y coordinate in our vertex. So here, my minimum is negative 8. And the curves at X equals negative 2. All right, so once again, whether we have a max or a min, always going to be the Y coordinate in our vertex. It always occurs at the X coordinate of our vertex. All right, we have a minimum if it opens up, maximum if it opens down. By it, I mean the parabola. And we can tell whether it opens up or down by our A. The A is the very first, our leading coefficient, if given in general form. All right. What's the domain for this function? Say it again. All of the real numbers are from negative infinity to infinity. We're dealing with parabola. That's always going to be our domain, the entire real number system. All right. What about our range? Perfect. Open bracket, negative 8 to infinity. All right, remember that if it opens up, it reaches up towards infinity for our range. If it opens down, it reaches down towards negative infinity for our range. And we're always going to keep the Y coordinate in our vertex for our range because the range is, by definition, all the Y values on our graph. All right, once again, for our x-intercepts, you can always use the calculator, plugging in A, B, and C. In this case, my A is 1, B is 4, C is negative 4, or you can work it out by hand using the quadratic formula. In this case, it would be, I'll just work it off to the side here. Negative 4 plus and minus the square root of 4 squared, or 16, minus 4 times A times C, or 4 times 1 times negative 4. This is all being divided by 2 times A. Because our A is 1, just going to be divided by 2. So that's going to give me negative 4 plus and minus the square root of 32 divided by 2, or negative 2 plus and minus 2 square roots of 2. All right, once again, if you're using the calculator, it's going to give you negative 2 plus and minus some, plus and minus a decimal, non-repeating, non-terminating decimal. That's because the square root of 2 is an irrational number. All right, nonetheless, for our x-intercepts, it's going to be 2 plus and minus 2 square roots of 2, comma 0. That's 2 x-intercepts, 2 plus 2 square root of 2, and 2 minus square roots of 2. For my y-intercept, Remember that implies that our x is 0. And my y-intercept is going to be -4. Remember, in order for us to find y-intercept, that implies that x is 0. So this would be 0 squared plus 4 times 0 or 0 minus 4. So that's 0 minus 4. My y-intercept is 0 negative. All right. So if we want to sketch this graph, or we want to write this in standard form, the f of x is equal to a, which is understood to be 1. I need for us to write it, times x. In this case, x plus 2 quantity squared plus 8, excuse me, minus 8. All right, so remember with the vertex, take the opposite of what we see for x, exactly what we see for y. And if we were sketching this graph, I'll try to make this fit down here. We don't have our vertex at -2, -8. So we go to the left 2, down 8. That's our minimum value. We also know that our y-intercept at -4, our x-intercepts aren't exact, so we're not going to be happening in between two values. But keep in mind, if we really want to know what those x-intercepts were, as far as where they are land on the graph, we can always just sketch the graph using our graphic calculator. So our vertex, put up here -2, -8, y-intercept 0, -4, and the parabola opens up, and we're showing that we have a minimum value. All right. Any questions on this example? All right, so this time we're given the function f of x is equal to -2, on parentheses, x plus 3, quantity squared, plus 5. All right, just checking for understanding. Is this one in general form or in standard form? Standard form. So we should be able to look at this and tell right off the bat what our vertex is. Anybody want to take a guess? What is our vertex here? -3, +5. All right, remember, if it's given to us in standard form, we take the opposite of what we see in parentheses for our x coordinate, or our h is -3, exactly what we see at the end for our y coordinate. So y is +5. This parabola, does it open up or open down? And how could we tell? There you go, it opens down. And when you say it's negative, what are we referring to? What's -2? The a value. All right, so this one opens down. And if it opens down, this means we have a maximum. Whether we have a max or a min, it's always going to be the y coordinate of our vertex. So here we have a max of 5, and it occurs at x equals -3. What's the domain for this function? The entire real number system. Our -infinity to infinity. Well, our range this time, because it opens down, it's going to reach all the way down to -infinity, all the way up to +5. All right. Now for our x-intercept, our intercepts, this time, because it isn't given to us in general form, we just want to remember that our x-intercept implies that y is equal to 0. So we can actually solve this as 0, because that's f of x, is equal to -2 times x plus 3 quantity squared plus 5. Or we can solve this for x, and what our answers are is what's going to give us our x-intercepts for the graph. So the first thing I would do, subtract 5 from both sides, and then divide by -2. So we're having -5 over -2, or positive 5/2 is equal to x plus 3 quantity squared. You can take the square root of both sides to get rid of that squared term. So this is going to give me both positive and negative. Square root of 5 over 2 is equal to x plus 3. And to get the x by itself, we'll subtract both sides by positive 3. So we end up with negative 3 plus and minus. If we rationalize the denominator here for the square root of 5 over 2, it's going to give me the square root of 10 over 2. And this is actually going to be my x-intercepts. Negative 3 plus the square root of 10 over 2, and negative 3 minus the square root of 10 over 2. So as an order pair, we have negative 3 plus and minus square root of 10 over 2, comma 0. For my y-intercept, we have the order pair 0 and negative 13. Now, the way that we got that negative 13 for our y-intercept, remember y-intercept implies that x is 0. If we go back and plug in 0 into our original problem, we have 0 plus 3, or 3 squared, which is 9. 9 times negative 2 gives me negative 18. Negative 18 plus 5 gives me that negative 13 that we're looking for. So at the end of the day, we're still substituting 0 in for x, 0 in for y. It just may look a little different depending on where we start. But we start with the general form. It's a little easier as far as the substitution goes. If we have the standard form, it's going to be easier to find the vertex, the maxes, and the mins. All right, so you do want to be aware of where we're starting because it will feel a little different as far as working it out. All right, but we have everything we need to get a good sketch of our graph. I'll put it down here. So we know our vertex is at the order pair negative 3, 5. So we go to the left, 3, up 5. We also know that our y-intercept is at negative 13. So it's going to be way down below our x-axis. Now, for our x-intercepts, we have 2. Negative 3 plus the square root of 10 over 3. Oh, excuse me, square root of 10 over 2. And negative 3 minus the square root of 10 over 2. Biggest thing is that we show 1, where our vertex is located. 2, the parabola opens up or opens down. 3, how it affects if we have a max or a min, and it should be represented correctly. And 4, where our y-intercepts are. All right, and by that, I just mean is it above or below the x-axis. And I can't stress this enough. We can always plug in y equals negative 2 open parentheses, x plus 3 close parentheses squared plus 5 into our calculator. You'll get this exact same graph. So keep in mind, we just really want to cut down on the time it takes for us to get the graph. All right, as well as the information, and we can use the fact that we understand these things going into it to cut down on which multiple choice option we have on our test. Any questions on that example? So here, more the same. This time, we have an f of x is equal to x squared minus 6x plus 7. All right. Is this a standard or general form? We know it's general because we don't see the parentheses. So we have to use our formula to find the vertex. Remember the x coordinate is negative b over 2 times a, or in this case, h is going to be a negative 6 over 2. We're going to end up with positive 3 for our h part, for the h or our x coordinate in our vertex. All right, so for our k, we need to figure out what f of 3 is. We're going to replace every x in f of x with 3. provided we're doing that correctly, what we should get for our output, -2. So my vertex is the order pair 3, -2. Do we have a max or do we have a min here? Minimum, how can we tell? All right, so remember, if the A is positive, in this case, our A +1, means the parabola opens up, or we have a lowest value, so our minimum. Minimum is always going to be the y coordinate in our vertex. So we have a minimum of -2. It's always going to occur at x equals the x coordinate in our vertex. So in this case, x equals 3. Domain, like every other problem, the entire real number system are from -infinity to infinity. Our range, because it opens up, it's going to reach all the way up to +infinity. It's going to reach all the way down to our minimum, or our range is going to be open bracket, -2, infinity. All right, our x-intercepts, and we can use the quadratic formula. So here, our x-intercept, we're going to have 2 of them. 3 plus and minus square root of 2, comma 0. Here we use the quadratic formula. And we've seen that we've done this a couple times. And keep in mind too, you can also use the calculator. And for the sake of time, I'm just going to go ahead and give you what the x-intercepts are. What is our y-intercept going to be? 0, 7. And for our y-intercept, especially if they give it to us in general form, all we got to do is replace our x with 0. So we have 0 minus 0 plus 7. Our y-intercept is 0, 7. All right, so if we have a sketch of this graph, our y-intercept is at +7. We also know that our vertex is at the order pair 3, -2. We also know our parabola opens up, and we also know that our x-intercepts are going to be irrational numbers, so they're going to land in between 2 values. All right, so that's what the sketch of our graph should be. Once again, we always just plug in the function x squared minus 6x plus 7 into our graphic calculator to be sure that what we expect is what we get for the graphic function. All right, and we got 2 more that I want to go over. One dealing with a fraction and another dealing with no x-intercepts. Is anybody still copying for this one? So here we're given the function f of x is equal to 2x squared plus x minus 6. Here they're given this function in the general form. So to find our vertex, we're going to have to use h is equal to -b, or in this case, -1 over 2 times a, or -1 over 2 times 2. So -1/4 would actually be my x coordinate for my vertex. I have to find my k, or the y coordinate. That'll be f of -1/4, or we'll have 2 times -1/4 squared plus -1/4 minus 6. Now the fractions could be an issue, but honestly, depending, if you have a graphic calculator, it's a way that you can use your graphic calculator to where it'll spit out a fraction to you. That's going to be different depending on the calculator that you have. But whether it's a Casio or a TI, I'll be able to show that to you, and so will anybody else in the math lab. So plugging this into our calculator, what we should get for our output, or the y value associated with an x of -1/4, is -25/4. So our vertex will be the order pair -1/4 and -25/4. Our A is positive, actually +2 here. So we know the parabola is going to open up, but we're going to have a minimum value. And our minimum, which is -25/4, always the y coordinate of our vertex, occurs at x equals -1/4. The domain, -infinity to infinity. This is true for every parabola. For our range is going to be open bracket, -25/4, comma, infinity. Two x-intercepts. Just like we did before, find the x-intercept. C is -6. What you'll get is your answers. It's 3/2 and -2. So our x-intercepts is going to be +3/2, comma 0, and -2, comma 0. The y-intercept, the order pair 0, -6. A good quick sketch of this one. We know we have x-intercepts, -2, 0, and 3/2. 3/2 is really just 1 and 1/2. We also know that our y-intercept is at -6, and the vertex -1/4. We're going to the left 1/4 of the unit and down to -25/4, which is really -6 and 1/4. So it's a little bit past that point of -6 on the y-axis. So this is a good sketch of our graph. And keep in mind, we can always plug that right into the calculator and we should get the exact same thing. Any questions on that one? So the last one, type of problem that doesn't have any x-intercepts, still dealing with the quadratic though. Here we're given f of x equal to 2x squared plus 4x plus 5. All right, so because it's given to us in the general form, to find our x coordinate, it will be a -b, or in this case, -4, divided by 2 times a, or 2 times 2. So we'll end up with -1 as our h. And we have to evaluate f of -1 to get our k, or our y value. F of -1 means you replace every x in f of x with -1. Provided we do this correctly, we should end up with +3. And so our vertex is the order pair -1, 3. My a is positive, so we know that the parabola opens up, and we're going to have a minimum value of 3. This occurs at x equals -1. Domain -infinity to infinity. The range, bracket 3 to infinity, because it opens up and it goes up all the way to infinity. We actually have no x-intercepts. The way that we can tell is if we were to use the calculator and plug in a equal to 2, b is equal to 4, c is equal to 5, you get imaginary solutions for your answers. So we have imaginary solutions when we're using that quadratic formula or our calculator. That means we don't have any x-intercepts. And we'll see why when we sketch the graph. But my y-intercept, which I have 1, is a pair 0, 5. The y-intercept applies to 0. So we end up with 0 plus 0 plus 5. Solve that. Also, we're sketching this graph. 0, 5. That's going to be my y-intercept. My vertex is the order pair -1, 3. So there's a left 1 of 3. So my vertex parabola opens upward. So you can see why we don't have any x-intercepts, because the parabola is above the x-axis and it's moving upward, so it never actually hits the x-axis itself. And that's going to be the last type of problem we have. We're going to see in section 1. Remember, the homework that is posted on Blackboard, try 3.1. Chapter 3 only has 4 sections. So we're going to go with 3.1, 3.2, 3.3, and 3.5 so that we can get that last test in right before spring break. Okay? So do keep that in mind that this test is going to go quicker than the first 2. So keep that in mind and make sure that you're picking up with the homework. We should have decided a little bit here today. You don't have a question.